Morning students, today's topic is converters or control rectifiers. Converters are used to convert the AC signals, AC input signal into the DC output signals. This is known as rectifier or converters. There are two types of converters. One is controlled converters or rectifiers, or uncontrolled rectifiers or converters. In controlled rectifiers, we use the thyristors as a switching element, and in uncontrolled we use the diode, and there is no triggering in case of the uncontrolled rectifiers. So first topic is difference between the uncontrolled and the controlled rectifier. Controlled rectifiers, in which we use the thyristors and diode, and in uncontrolled rectifier we use the diodes. Triggering is not required in case of uncontrolled rectifiers, but triggering is required in case of the controlled rectifiers. There is a power wastage in case of uncontrolled, and there is no power loss wastage in case of the controlled rectifier. We use the diode as a in the circuit of uncontrolled rectifiers, and thyristor in case of the controlled rectifiers. There is a continuous control of the output is not obtained in case of uncontrolled, and continuous control of the power is obtained at the output section of the controlled rectifiers. And the next topic is single phase half wave control rectifier with resistive load. So in half wave control rectifier we use the single thyristors or diode. As we know that half wave rectifier we use single diode, and full wave rectifier we use the two diodes. And in half wave rectifiers, the output is only for the positive half cycle, and there will be no negative in the negative half cycles. In the full wave rectifier we have the positive as well as negative. We get the output for both the positive as well as the negative half cycles. So single phase half wave control rectifier with resistive load, this is the circuit diagram for this single phase half wave control rectifier, in which we can see there is a thyristors, and resistive load is across the output side, and input is given in the input side, and Vt is the threshold voltage. This is the thyristor voltage, sorry, this is the thyristor voltage across the thyristors, and SCR will conduct only in the forward bias when the anode is positive and the gate signal is applied across the circuit. Only then the thyristor will be in a on state, and thyristor will be in a blocking stage when it is in reverse bias, and it will block the current until it will be triggered, or it will be in a on stage. There will be some delay angle, that is alpha, and also known as the firing angle. Positive gate signal is applied between the gate and the cathode, then the thyristor will be turn on, and the supply voltage will be appeared across the load resistance, that is RL. So working for positive half cycle, thyristor will be in a forward bias, and gate signal is applied across the thyristor, so output will be obtained, and the thyristor will be coming from the forward blocking mode into the forward conduction mode. And for the negative half cycle, the thyristor will be in a reverse bias. You can see in negative half cycle it is negative, it is positive, so it is in reverse bias, and for positive half cycle it is a positive, it is negative, it is a forward bias, and in negative half cycle it is in a reverse bias, so no current or no voltage will be obtained across the output. And firing angle, that is noted by alpha, it is the angle measured from the instant that the SCR gets forward bias to the instant it is triggered. That is known as the firing angle, and that is noted by alpha. You can see the waveform of single phase half wave control rectifier with resistive load, in which we can see there are different things. One is you have the input V in, this is V in, and then you have the output. To get the output we need gate pulse, that is IG should be applied across the thyristor gate current, and then you get what output voltage. Then there is a output current, that is IO will be flowing through the resistive load, and last one is that is your VT is the thyristor voltage across the thyristor VT. So there are 5 terminals, that is input, then you are having the gate pulse to get the output, to get the thyristor into on state, then you get output voltage, then output current, then there are Vt, that is the thyristor voltage. Okay, when we supply the input is, this is given positive as well negative half cycle. For the positive half cycle, what happened? And positive half cycle, when we get the positive half cycle and gate pulse, this is the gate pulse and this is known as the alpha, that is firing angle. When we supply the gate pulse, then you get thyristor will be in a, and this will be in a on state, and you get the output, that is VO and IO, current and output across the load, that is same output. When we apply the same output as we given at the input side is obtained at the output side VO, and same current will be flowing through the circuit. And what happened with the VT? Until we have supplied the gate pulse to this thyristor will be in off state, so all the voltage which has been supplied by the V in, it will be, there will be voltage drop across the thyristor until we have supplied the gate pulse. So whatever the input is supplied from here, that will be stored in the here up until we have supplied the gate pulse. Whenever we have supplied the gate pulse, the thyristor will be on, it will be closed circuit, and all the voltage will be supplied from V into the V out, and there will be no voltage drop across the thyristor, so it is coming to the 0, and there will be no voltage drop across here. We get the output voltage and the current. And for the negative half cycle, what happened? For negative half cycle, when we supply the negative half cycle across here, it is negative, it is positive, and it is in a reverse bias, so it will no voltage or current will be obtained across the output. So you can see here, for negative half cycle and gate pulse applied or not, it hardly matters, and it will be no output voltage and output current will be, it will be 0 for negative half cycle. Here up to this is, suppose this is pi and this is 2 pi and this is 3 pi. Okay, and here there will be no voltage and no current, but you will having the thyristor voltage, because we have supplied the input from V in, and this will be voltage, all the voltage drop which has been supplied by from here, it will be stored here, that is across the VT, and whatever the input voltage is given, that will be stored across the VT, same voltage up to here. And again the next positive half cycle, it will again supplying the gate current, so output will be triggered and it will be getting the output voltage and output current same. And what about the VT? It will be again, when we supply the positive voltage, it will be having the same voltage which is given at the input up to the gate pulse is applied across the thyristor. Whenever the gate pulse is applied, the thyristor will be on state and all the voltage will be drop across the resistive load, so it come to the 0, and we get the output and output current across the RL. Thank you so much.